Hello, Algebra 2 students. Today is the last day of new notes for this unit, and it's about loan payments. Some of these formulas are going to look kind of crazy. You do not have to memorize any of them. You'll always be given the details and how to use them. You just have to make sure that you can set it all up and work with it. All right. So this first example kind of walks us through like how it gets developed, and then we'll go straight to the big old formulas. So for loan payments, so college loans, that should probably be pretty important to you guys. Maybe even car loans, home mortgages later on. Large amounts of money. They're saying you're borrowing from the bank where the interest is calculated typically on a monthly basis. And then regular payments are also made. So they're going to charge you each month the interest, but then you're also going to make payments every month, maybe even twice a month, depending on, your loan. It's saying it's a really complex process and it ultimately involves geometric series. So that's why it ends up in this unit here, right? So this first part, it says, let's say you decide to go to Syracuse University. It's one of my alma maters. And it says you take out a school loan for $200,000. You want to make payments of $1,600 each month to pay it off after graduation, of course. The bank is going to charge you a 4% nominal yearly interest applied monthly. All right, there's a lot of stuff going on there. Excuse me. So it says, what is the amount owed at the end of the first month? Show the calculations that lead to your answer. All right. Well, they're going to charge you interest right off the bat. So let's talk about what's going on here. These are your payments. We're not worried about that just yet. So you took out a $200,000 loan, and they're going to charge you 4% applied monthly. All right, so a couple things. 4% would be your R value. And we've talked earlier in the unit how that gets turned into then a decimal. So that's 0.04. But because they charge you monthly, they don't charge you 4% every month. They divide it up 12 ways so that by the end of the year, you end up being charged the full 4%. So anytime you see this applied monthly, you're going to divide by 12 for that part. So that's just the first thing. So when it says how much do you owe at the end of the first month, to calculate the interest, we'd take the amount you borrowed, 200,000, and then you're going to multiply that by not just this, but 1 plus that, right? The reason for the 1 plus is you still owe the 200,000 and then plus that little extra right there. So if we do that, grab your calculator right now. Let's do 200,000 times 1 plus 0.04 over 12. And so now what you owe basically is another $667 on top of the 200,000 that you already owed. So that's why you get the 1 plus. If we just calculated this, then it would be, you'd just add the 200,000 to it. Okay. So when I say calculate the interest, it's really calculate what you owe plus the new interest. Whoops. So we are now up to $200,000. We'll say 666 and 67 cents. Okay. And now you make your first payment. So they said you're going to pay $1,600 a month. So if we subtract 1,600 now from that, because you're paying them back some money, minus 1,600, now you owe $199,000 $199,066.67. So after month 1, they've charged you interest, you made a payment. This is now your balance. So here's the crazy thing. You gave them $1,600, but how much did your amount come down? Well, that's the next question right here. All right. So when it says how much of the first month's payment went towards paying off the principal is the bulk of the loan that you made to begin with. Oops, let me slide over here. So that's the $200,000. All right. So that's the original $200,000 loan. And when they say the principal, all right, well, since it started at 200,000 and now what's left is $199 and $66.67. If we take that little difference, so let's go 200,000. I think that's the right number of zeros minus, we'll grab that guy. All right. So you paid off $933. So of that $1,600 that you spent, $933 went towards paying off the loan. The rest of it went towards interest. So when you take 1,600 and you subtract what went towards the principal, right? So if we take 1,600 and we went and subtract this much off, right? It really means that only this much of it, or excuse me, not only, that much of it went towards just interest all by itself, which is depressing, but that's true. So anytime you take out a loan, unless it's 0% interest, a ton of the money that you pay each month is going towards just the interest that they're charging you for giving you the loan in the first place. So this much came off of the principal, this much went towards what they were charging you, which kind of makes sense because that was that 666 that got tacked on top to begin with. All right. When it says determine the amount you owe at the end of a second month, technically we could play that game one more time. So I'm going to do this one kind of quick just so you can see it. But we're not going to necessarily go month by month in the future. So don't feel like you have to be able to recreate this every time. What you would do though is you would take what your balance is. So the 199,066.67, and you'd multiply it again because they charge you interest by the 1 plus 0.04 over 12, right? If I do that, I can run up here and grab that number and then multiply it times 1 plus 0.04 over 12. And that brings it back up to 199,730.22. But then you pay $1,600 off. So it's this little balancing act of they charge you, then you pay them some. Then they charge you, then you pay them some. So it keeps going up and then down and up and then down. So it's a very slow process to pay something off completely. So the balance here now is 198,130.22. All right. So this would be your balance at the end of 2 months. And so when I say the balance, that's how much you would still owe them after 2 months. Okay. When it says the amount owed at the end of a month actually forms a sequence that can be defined recursively. Recursively means that you would have to tell me the first term and then give me the rule. Well, if you think the first term was the 200,000, right? And then what were we doing? Well, we took this term, we multiplied it by that 1 plus 0.04 over 12, and then we subtracted 1,600. So as a recursive formula, you can say multiply the term before it by this, and the term before it would be a sub n minus 1. And then we would subtract 1,600 off of that. And you would keep doing that. This is what makes it a geometric sequence, right? But what we ultimately want to look at is if we start adding all of those values up, because that's how much we would want to look at is, like how much do you end up paying total in the end? If we calculate up all the payments and so on, that's where the future formulas are going to come in. Now, before we do that, we have one last quick example to look at, and that is this guy. Example 2 says if a person took out a $150,000 home mortgage and they had to pay 5% yearly interest, why would it be unwise to have monthly payments of $500? All right. Well, if we actually calculated this one like we did the last one, 150,000, it's 5% this time. So it'd be 0.05 broken up 12 ways. All right. And so if we do 1 plus 0.05 over 12, let's just calculate how much it would be before you even made a payment. So 150 and then times 1 plus 0.05 over 12. That would bring you up to 150,625 once they charge you the interest. If you then make a payment of $500, something should be sticking out in your brains right now. That's not even enough money to break even. You would have to pay $625 a month just to keep that loan flat, which would be awful. You would never pay it off, right? So when it says, why would it be unwise to make payments of $500? It's not enough money to even break even, which sounds weird, to even break even, but you get the deal. 625 would break even. This, you would be upside down on your loan is what they say, that where you end up owing more money later on than paying off money. So it would just be bad in lots of ways. All right, let's hop on down to the ones that we said it's going to form this geometric series, and that's why we get into it. So it's saying it's nicer to have a formula that's going to calculate it versus us trying to go month by month by month. Okay, the general breakdown of this, A sub n is going to be the amount you still owe after making n payments. What this kind of does is it's the amount that you end up paying the bank in interest and then the amount you've paid back. I wish it was actually that simple, but that's kind of how I like to think of it, is this is how much they're charging. This is how much you pay back. That difference is how much you're going to owe, all right, in the end of it. So when you look at this big, old, crazy formula, which you do not have to memorize, we just have to know what to plug in. So you see a bunch of variables here. You have P, you have N, you have R, you have M. P is going to represent the principal value. Which that's the amount the loan starts at. Right. N, that's the number of payments made on the loan. Right, which essentially means the number of months, because almost every question we do will just be a monthly payment. R is your rate as a decimal, but then divided by 12, because the over 12 was to make it a monthly rate. And then M is the monthly payment. Okay, let's see if we can make this guy work. So it's saying, let's go back to our $200,000 loan. Ugh, gross. Made at 4% yearly interest. We're paying off the loan, $1,600 a month payment. Find the amount owed after 10 years or 120 payments. All right, when you do these questions, I really want you to start by writing down what those four values are, P, N, R, and M, okay? So P, the principal, it starts at $200,000. Right. The N value, that's the number of months, which they say 10 years or 120 months. So it's done there for you. If it wasn't, we would just do 10 times 12. The R, it was 4%, so it's 0.04, but then divided by 12 because it's a monthly installment. And then the M value, that's the monthly payment. So you're paying $1,600 a month to pay off that loan, which, just FYI, guys, that's a lot of money. That's like what a mortgage should be for like your house, okay? So if we want to calculate how much is still left, we want to find A sub 120. All right, using the formula up above, let's plug in. So A sub 120 would be equal to, so I'm plugging into this right now, P, and then times 1 plus R to the N. So 200,000 times 1 plus 0.04 over 12 raised to the n power, raised to the 120. And then minus 1,600 times 1 minus, and then in parentheses, 1 plus 0.04 over 12, and then raise it to the n power, to the 120. All right, close up that parenthesis. Divided by 1 minus, parenthesis, 1 plus R, so 1 plus 0.04 over 12. You can see right now, this is going to be more about being neat and being organized and typing things in correctly than it is almost about the algebra itself. Right? What I would strongly suggest is, if you take a look, you have the same expression used in 3 different places. This expression, this 1 plus 0.04 over 12 is here, it's here, and it's here. So I'm actually going to take and I'm going to store that value in my calculator as X to make it a little easier to type all this in. So it's a little reminder to store something in your calculator. We did this earlier in the year. Let me slide over a little bit. I'm going to let me zoom in so you can see better on my calculator too. 1 plus 0.04, 04 over 12. I can hit enter, that's the number, and to store it, the store button is down here. That my STO right there. So I can hit store and it's going to pop up this little arrow next to it and then in X. And then when I hit enter, anytime I hit X on the home screen, that's the decimal value that it has stored in there. All right. And you can change that as often as you want. But for this problem, that's what I've got stored in there at the moment, which what that means is I'm going to now type all this in using the value that's stored. So it's going to be 200,000 and then times X to the 120th power and then minus 1600, 1 minus X to the 120th power, and then all over 1 minus X. For me, that makes it easier. It's up to you, but I'm going to take advantage of being able to store it. So if you store it, if you're going to do this with me, store it first and then try it. So now I can type it in as 200,000. Make sure I have the right number of zeros. 200,000. All right. X raised to the 120th power. And then minus, and then I'm going to do a little alpha y equals here. Alpha y equals, all right, 1600 times 1 minus X raised to the 120. And then close up that parenthesis. And then on the bottom, 1 minus X. All right, so I'll leave that there for a second so you can kind of see everything that I've typed in. So the 200,000, X to the 120, and then minus 1600, 1 minus X to the 120, all over 1 minus X. When you're ready, hit enter. What we should have here is $62,566 and about 85 cents. That is how much is still owed on this loan after making 10 years worth of payments, right? So that's what this means. This is the amount still owed after 10 years of payments. Now, if you tried it and you stored everything in X and it didn't work out, I would say pause the video, try it one more time. If it still doesn't work out, then that's what you're going to ask for help on in class tomorrow. Otherwise, let's keep moving. There's one more example I want to do with you now, and then maybe we'll save the last one for class. So when we flip on over here, this one has the same formula. So it says using the same formula, how much money would still be owed on a car loan after 3 years when the car was purchased for $23,875, a yearly interest rate of 8.5%, and then $500 monthly car payments. Okay. So something to keep in mind here, as long as you're paying monthly, then the interest rate is always going to be broken up into monthly installments. So you're always going to do the divided by 12 part. So just an FYI. All right, over here, let's state what we know. So the principal, that's how much you're buying the car for, or the amount of the loan at the beginning. All right, the end value, well, it's 3 years. So 3 years times 12 months, that would be 36 payments, or 36 months, so 3 times 12 there. The R value, that's 0.085 divided by 12, since it's a monthly thing. And then how much you're paying each month. It's $500, right? So we want to see how much do you still owe, after 3 years. So let's plug on in. So A sub 36 would be equal to 23,875, and then times 1 plus, all right, in for R, 0.085 over 12, raise that to the 36 power. All right, and then minus 500 times 1 minus, I'm going to tell you right now, I'm going to store this, and this as X. So I'm not even going to fully write out all that expression. You can, but I'm going to tell you right now that I'm going to store that in as X. So I'm just going to call this an X right here, right? Raised to the 36 power. And then all over 1 minus, again, I'm going to put in an X here. And to make it clear, this is what's going to go in for my X. So before I go to my calculator, whoops, let me grab my, or before I type the whole thing into the calculator, what I meant to say was let's put this in for X. So 1 plus 0.05 over 12, which is pretty messy. So let's store that in X and just hit enter. Now I can type in everything with the X's. So what that's going to be is 23,875 times X, and then raise that to the 36th power. And then minus, let me move this over so it's out of the way, minus alpha y equals, oops, let me get out of there, minus, and now alpha y equals 500, and then times 1 minus, and then I can put that little x in parentheses or not. If it makes it easier to look at, I will, over 36, close up that top parenthesis, and then on the bottom, 1 minus, and again, just a little x right there. All right, double check that everything is done correctly, and then hit enter. And then from here, what I am looking at, oh, you know what I just realized I did? I copied, I don't know why I copied it like that. I copied this part wrong. Oops. So in case you're watching going, Mrs. Mara, what were you doing? 0.0. 85. Well, guess what? This becomes a pretty easy fix. All right. I didn't mean to actually make that mistake, but let me fix it. I can do this and store it in X. So if I go 1 plus 0.085 over 12, and now store that in X. Whew. Okay, now let me go grab that expression. All right. There we go. That's the answer I was looking for. Okay, I actually checked my notes for once, guys, and realized I'd made a mistake. So by fixing that, I can then quick fix that value. So what should be left should have been $10,360.76. So after making those $500 payments for 3 years, they still owe a little more than $10,000 on the car. All right, just goes to show, be careful. Make sure you type the right thing in, and this way you get the right answer. All right, have a good one, guys. Go answer that post-video question. Thanks.